Good evening, my dear students. Recently, we have started a Bessel function. We have seen it occur in the previous classes, simple occur definitions and small problems. Now, in today's class, we'll start recurrence relation for Bessel function, which are very, very important for 5 marks. Definitely, one will be there in the question paper. Recurrence relation. Today's class will see recurrence relation. Recurrence relation for Jn of x. The very first recurrence relation, that is d by dx of x to the power of n Jn of x, which is equals to x to the power of n into j n minus 1 of x. This we have to prove. This can be in the textbook any number, but this I have picked up as first recurrence relation for our class. So by using the Bessel function of a first kind, we can show that d by dx of x to the power of n jn of x, which is equals to x to the power of n into jn minus 1 of x. So by definition, we know that, or we know that Jn of x, that is equals to summation r is equals to 0 to infinity minus 1 to the power of r into 1 divided by r factorial gamma of n plus r plus 1 x by 2 to the power of 2r plus n. Now we will consider the LHS. With the help of LHS, we will show the RHS. Consider LHS d by dx of x to the power of n into jn of x, where we'll use the jn of x. This jn of x, we will use the definition, that is equals to d by dx of x to the power of n into summation r is equals to 0 to infinity minus 1 to the power of r into 1 divided by r factorial gamma of n plus r plus 1 into x by 2 to the power of 2r plus n. Now outside what it is there, it is a differentiating with respect to x is there. So that remaining terms, these terms we will shift to, we'll write outside that differentiation, because differentiation is applicable only to the x term, not to the r, not to the n. So we can write that is out summation r is equals to 0 to infinity minus 1 to the power of r into 1 divided by r factorial gamma of n plus r plus 1 into even this 2 to the power of 2n plus 1 also we can write out. So 1 divided by 2 to the power of 2r plus n. That is also constant. So I am writing out d by dx of x to the power of n into x to the power of 2r plus n. If the bases are same, what we are going to do? We are going to add the powers. So this x to the power of n and x to the power of 2r plus 1 we can add, which is equals to summation r is equals to 0 to infinity minus 1 to the power of r into 1 divided by r factorial gamma of n plus r plus 1 into 1 divided by 2 to the power of 2r plus n 2r plus 1 into d by dx of x to the power of 2r plus n plus n. N plus n, that we can write, it is equals to 2n. Summation r is equals to 0 to infinity minus 1 to the power of r, 1 divided by r factorial gamma of n plus r plus 1 into 1 divided by 2 to the power of 2r plus n into d by dx of x to the power of 2r plus 2n. So from here we can take 2 as common. First we'll do the differentiation. Why to drag long summation r is equals to 0 to infinity minus 1 to the power of r into 1 divided by r factorial gamma of n plus r plus 1 into 1 divided by 2 to the power of 2r plus n into where your what is the formula, basic formula, d by dx x to the power of n, that is equals to n into x to the power of n minus 1. So these term will be treated as completely n. So what we are going to get from here, that is minus 1. So now apply that one. 2r plus 2n into x to the power of 2r plus 2n minus 1, right? Where we also know that gamma of n plus 1, that is equals to n into gamma n. So these one we can treat it as equals to completely n, this term. So when you're going to apply this formula, what you're going to get, summation r is equals to 0 to infinity minus 1 to the power of r into 1 divided by r factorial n plus r of gamma of n plus r into 1 divided by 2 to the power of 2r plus n into 2 2 r plus n into x to the power of 2r plus 2n minus 1. So now you see this n plus r and this n plus r will get cancelled, which is equals to summation r is equals to 0 to infinity minus 1 to the power of r, 1 divided by r factorial gamma of n plus r into 1 divided by 2 to the power of 2r plus n into 2 x to the power of 2r plus 2n minus 1, where this 2 I will take it to the down, so it will become 2 to the power of minus 1. Summation r is equals to 0 to infinity minus 1 to the power of r, 1 divided by r factorial gamma of n plus r into 1 divided by 2 to the power of 2r plus n into 2 to the power of minus 1 x to the power of 2r plus n minus 1 into x to the power of n. 2n, what I did, I have taken out from this one. If the bases are same, powers are going to be added. So what I did, I separated one n, because what we need required one, according to that I am moving. If the bases are same, powers are going to be added. It is equals to summation r is equals to 0 to infinity minus 1 to the power of r, 1 divided by r factorial gamma of n plus r into 1 divided by 2 to the power of 2r plus n minus 1 x to the power of 2r plus n minus 1 into x to the power of n. Right. Now what? This summation values for r. So this x to the power of n, I can write completely out of that summation. Other side, what we have taken, d by dx of x to the power of n into Jn of x, which is equals to x to the power of n into summation r is equals to 0 to infinity minus 1 to the power of r into 1 divided by r factorial n plus r plus 1 of x by 2 to the power of 2r plus n minus 1. Now still it is not in the definition form, because here, oh, I have written here a curve 1 r extra. The next step we will take. Now, so according to the definition, we need here as an what, n plus r plus 1 we need. So what we are going to do, we will add 1 and we will subtract 1 over there, so that it should fall into the definition form, which is equals to x to the power of n summation r is equals to 0 to infinity minus 1 to the power of r into 1 divided by r factorial gamma of n minus 1 plus plus right plus r plus 1 of x by 2 to the power of 2r plus n minus 1. Now you see this is completely in the form of your Bessel definition, first kind of order n, where in place of n we are having n minus 1. So which is equals to d by dx of x to the power of n into j n of x, which is equals to x to the power of n into j n minus 1 of x. Hence proved what they have asked you to do. We have shown that is what LHS is equals to RHS with the help of the definition. If you have liked my way of teaching, like that video and share among with your friends. Maybe your one share can save that person ka paper. It is important one. Thank you.